Okay, you want to do it? Do you want to share your
Yeah, I'll share.
You want? Okay.
Okay, can you see my screen?
Yes.
Try to do this. Sorry about this morning. My phone alarm didn't go off. Question 3 is the normal probability. So when you're taking a sample size of the mean equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed?
Yeah, so I took notes. Let me look. I think I put normal.
Could we use this right here? Oh, I don't think that would work. It doesn't work. Yeah, I think you're right. I think it's normal.
Yeah, like in the homework.
Right. If you were to choose from this thing or whatever. Right.
Yeah, it had a similar question.
Yeah, I remember that too. Yeah. There's sample size n equals 100. What is the shape of distribution? Means histogram when the parent population is right skewed.
See a big number. This is what I learned. In the sample size, even if it's the sample size is big, is more than 30, that makes it normal. And I think the first one. Okay, let me
Can you
look.
say it one more time? Can you say it one more time, Anna? I'm sorry.
Size B, that one is 100. Then even though it's right skew, it would be normal.
It would still be skewed left.
Yeah.
Because it's a larger number, right? So.
Listen, and the lesson it says if the parent population is so it's right skew or left, right?
Yeah.
Then sample distribution will be approximately normally distributed if the sample and 100 is really big. Because in the lesson says that whatever is over 30 will be large.
Okay.
Now, what was the first one?
Skewed right.
So that will be number 4 will be normal.
Normal.
But what was the one before?
The one before says it's 5.
Came out with that one. So when you're taking a sample, so that one small is 5. It's less than 30, right? But it's
Yeah.
when the parent population is right skew. So I don't remember if the parent population is normal.
I think if it was when it's normal.
So 3.1 is when I'm reading, yeah. If the parent population is normal, then the sample should will always be normal.
The parent population is highly skewed and require a larger sample size.
Yeah, and the third one is about 5. So if the parent population is almost normal, then a sample size of 5 will approach it. If the parent population is 2, but it will require a large sample size. So it may be right skew. Let me look
What does it say the question is? Histogram on the parent population is right skew.
Yeah, it's right skew because it's small. The sample size is small. Yeah, I'm looking at my quiz. The sample small. So in the book, it says if the is skewed, then it will require a large sample size to be assured that it will be normal, right? So because it's small, then it will just stay like the population, like the parent population, which is right skewed, so it's the same.
Yeah, I think you're right. I agree with you on that one. Skewed, right.
And then 4, it will be because the sample size so big is 100, then it will be normal.
A normal distribution.
I remember.
You're taking a sample size. What is the shape of the distribution?
Whatever.
What was the first? What was this? Is that the same question? You're taking a sample size.
Yeah, so 3 skew right because it's big. And then the next one, so the sample size small, when it's normal, it will always be normal. It doesn't matter if it's small or big.
Or big. If it's normally distributed, it's always going to be normal distribution.
Yeah, the first it says, if the parent population is normal, then the sample distribution will always be normal.
Okay, it says that in the
No
book.
matter how many observations are selected. So even if it's small or big, if the it will always be normal.
Okay, yeah, that makes sense. I mean, yeah, you're right. That's in the chapter. When you're taking a sample size of n, what does the shape of the distribution mean? Histogram on the parent population is normally distributed. It doesn't matter, does it? It's the same thing as.
Now if the population is normal, it doesn't matter if they do it with 5 people or 100 people, it would always be normal. That's like the very first one there.
Yeah. When one of the distribution of means be normally distributed, choose all the correct responses. Data are drawn from populations normally distributed and the sample size is small. Data are drawn from a population that's normally distributed and the sample size is large. Data are drawn from a population that's right skewed and the sample size is small. Data are drawn from a population that's right skewed and the sample size is large. So when would the distribution means be normally distributed? Oh, let's see here. All right.
They are drawn from distributed and the sample size is small. Okay, let me see the question again. There are 3 that are true, false in that one. So when would the distribution means be normally distributed?
It wouldn't matter. I guess to me, would be the
Yes.
small and large, right?
So the 2, and the 2 first ones, it's a population is big or it doesn't matter. It doesn't matter if the size is small or large.
Right.
It will be normal. So those 2 are true.
And then I think it's data are drawn from the population is right skewed and the sample size is large, right? That's usually.
Yeah, but when there is skewed to the right or left, it needs to be a large to be normal.
To be considered normally distributed or whatever, so.
If it's small, remember 5, I think.
Right.
Right skew, then it will stay right skew. But if it's large, like 100, then it will be normal. Right?
Yeah, I agree with you. I think that's right. I mean, that's what it says in the chapter. That's what it, from the original, or the questions 1 through 5 at least. So, which of the following gives the best explanation of the central limit theorem? If the parent population from which data are drawn is normally distributed in the sample mean.
So that one is in the book. If you go to the very end, on the definition
of the central line theorem, it's right here.
like a little square box.
Right here.
Oh, I'm watching the video anymore.
The distribution of cell means is normal when
yeah,
X bar is normally distributed, or when, thanks to the central limit theorem, or sample size is large. Sample size is large, so
yeah, so we know the first one and the second one are not in. So it's between the two last ones. And something that I look and went through, also if you go in the book under the central limit theorem, I don't know how to say that. The second paragraph.
Is it this right here? Right here?
Where it starts saying, you have observed.
Central limit theorem works for every population when the standard deviation is defined. In other words, it will work for any distribution you find in the real world.
So it says the sampling distribution of the sample mean will be approximately normal if the sample size is sufficiently large.
Where did you read?
Oh, in the second paragraph, close to the bold letters, that says central limit theorem. Central limit theorem is 3, yeah.
Okay.
In the second paragraph, it starts, you have observed.
Oh, okay. Simulations. That if the sample size is large, the random variable.
Yeah, right.
X bar will be approximately normally. Sample size large. Fuck, is it this one right here? The sample size is large, the shape of the distribution of sample means will be approximately normal.
Yeah. Me now, because it asks you in different ways in the quiz too about this theorem. Something that helps me now is the shape of it will be, it'll be focused on the center. So it will be like this, like a little hill, like a little mountain, right?
Yep.
And with the other one is called, what is it called? LLN. The real large number. That one would always talk about being close to the population mean. So
okay, I see what you're saying. Yeah.
So
sample size is large. Sample mean exposed.
It's about the shape. It's how it's shaped. It's shaped like a little hill, like a mountain, and the mean is in the middle. So it's up. But then in population, sorry, in the LLN, the rule of large numbers, they'll be close. It doesn't matter which add, it'll be close to the population mean. So that's the difference.
Okay, okay. Oh man, it's getting harder.
This last one was bad for me, I think. I got to figure out though, but it got confused.
Use the following information. So let x be a random variable of the population mean equals 10, a population standard deviation 6, close sample size of 36 is dropped from the population. What is the mean of the distribution of sample mean?
Yeah. This is really easy, yeah. So the rule is that the mean of the distribution of sample means is always equal to the population mean, which is that little U sign stand, right? So there is no calculation there. You just take that number and put it there.
Put it in there, right? Yeah. Okay. What's the standard deviation of the distribution of sample means? Is that the same thing as putting 6 in there?
They're always the same. In question 9, population distribution of sample means is always the same number.
Which is 10, and then in the number 10.
Number 10 standard formula, right?
Yeah, standard deviation.
Which is 6 divided by the square root of the sample
size,
which is 36. It's a little formula there. So 6 by the square root of 36. The square root of 36 is 6. So 6 divided by 1.
So you take the standard deviation and divide it by the sample mean, and then you square root that. Is that what you said?
Yeah, to get the standard deviation of the distribution of sample means, it's all that word. So the formula is this, which is 6 divided by the square root of sample size, which is 36. So 6 divided by the square root of 36, and the square root of 36 is
6,
1.
right?
I mean 6. So 6 divided by 6 is 1. So the answer is 1.
1. Okay. Okay. I just want to make sure I got that right, because that's why I was for sure. Regardless of the distribution of population, if the sample size is large, means greater than 30, what would be the shared distribution of the distribution of the sample mean?
So remember how I told you, it doesn't matter if it's large or small.
It's always going to be normal.
It's always going to be normal.
What theorem would justify your response to the last question? No.
So that one was a tricky one for me because I get confused with the two definitions.
Yeah, you're right.
But the answer is, so I just took notes of what I study about the difference between them both, CLT. And this is what I wrote. It says, if the sample size is large, a normal distribution. Regardless of the distribution, If the sample size is large, what would the shape distribution of the distribution and sample mean? It would be always normal, right?
Yeah.
So that's why, regardless of the distribution system. So that's pretty much, question 11 is pretty much the definition of central limit theorem.
Yep.
Regardless of the distribution of the population, the shape, remember how I told you about the shape? When it talks about the shape, it's always CLT. The shape is normal.
Sorry, that was my child. Let's see. Then if you go up here, okay, I understand that. That makes sense to me. Standard deviation gets smaller. Okay, I'm gonna go with that. Right.
So question 11 is the definition of it.
Yeah, no, I see what you're talking about, because regardless of the size of the sample mean, or the sample, it will always be approximately. So
I was looking for your email address, and then in your profile that you like fixer-uppers.
Like houses and stuff? Oh, like the show.
Uh-huh.
Yeah. I do like that show.
Love it.
Yeah,
okay.
It's
that's it.
we have that one.
Okay, and then thank you for helping me with that. I didn't get your text until Sunday. That's okay. I just wanted to know how you got the answer. So I'm doing it wrong, because for the test, they'll probably ask something similar, and I didn't know how to get it right.
No worries. I missed 2 on that one, but I got the one that you were asking about right.